Just recently, the owner of the level uploaded a big number calculator, meaning it can handle crazy big numbers. Let's break down into different chapters starting with basic arithmetic. Yep, I'm definitely skipping this chapter. Next one, long arithmetic. Let's split into 4 parts. The first part will be addition. 1 second, the level takes a little bit to load. There we go. Wow, this is so cool. But first, let's find the sum of 456 and 785, and we are competing it with the Google calculator. If both hit the equal sign, you can see that the Google calculator displays the answer first. Next, the sum of 458,731 and 89,347. Surprisingly, the GD calculator took longer to calculate. Before we go to part 2, just realize that you can activate whole numbers. From now on, we are checking with the Google calculator to see if it is correct. Let's calculate the difference between 432 and 284. The GD calculator says 148. So does the Google calculator. But what happens if you subtract a bigger number, like 144 minus 510? We get the answer of minus 366. Moving on to long multiplication. And we are multiplying a 3-digit by 2-digit. Let's find the product of 462 and 16. While the goal for this video is to make the GD calculator answer very inaccurate. The GD calculator says 7,392. And how is it correct? What about both being 3 digits? Like the product of 839 and 737. Do you think that the GD calculator will get it wrong? Place your bets. There is no way. Before we go to part 4, you can change your key number. And when you hit the positive-negative sign, it lights up. And you can also change your equation symbol. How cool is that? For long division, we are doing many digits divided by a 1 digit, starting with the quotient of 692 and 4. I feel like that at one point. The GD calculator will get it wrong and inaccurate. Is the GD calculator correct? Yep, it is indeed. What about the quotient of 73,125 and 5? This must be somewhere near that. The GD calculator will get it wrong. Nope, but what happens if I divide by 0? We get actually, not yet.
1 second guys, I just got a message from someone. Let me check it out. How nice. Someone sent me a lovely message. Let me reply real quick.
Moving on to exponent. But first, let's calculate the highest and lowest numbers. I assume that the exponent is a 16-bit integer limit, which caps out at 32,767. Well, guess it's time to waste another. Bro, how did it calculate that fast? That is what the GD exponent calculator reached, but now it is no longer available. But if I go past the highest number, we get the answer of infinity. What about the lowest positive number? Like I said before, the 16-bit float, which goes as low as minus 32,768. I think this calculator just saved so much time calculating. But if you go past the lowest positive number, we get the answer of 0. For most calculators, going past the lowest positive number says 0. But something interesting happens on some calculators. Like on the Windows calculator, the lowest positive number is 10 to the power of minus 9,999. If you've never seen what happens if you go past the lowest positive number, it just says, overflow, which doesn't make any sense. Let's try tetrated to 2 as our next part. Did you know that if a number is raised to itself, we call it tetration? It's an operator that grows crazily quickly, like 9 tetrated to 2 is bigger than the population of the US. What about taking 69 to the second tetration? That's the same as 69 to the power of 69. Hitting the equal sign gives us 7.6 unquadragentillion, which is a big number. Also, is the GD calculator finally incorrect for once? Time to level up the tetration. We are tetrating to 3. Let's calculate 2 tetrated to 3. For the power tower rules, you always start from the top. 2 to the power of 2 is 4, and 2 to the power of 4 is 16. So that means 2 tetrated to 3 is 16. What about 3 tetrated to 3? 3 to the power of 3 is 27, but 3 to the power of 27 is greater than 7 trillion. But here's where it gets really big. 4 tetrated to 3 is so big that is even bigger than 69 tetrated to 2. I'm doing 4 to the power of 256 because there is only 2 numbers. What about 5 to the third tetration? Simply do 5 to the power of 3125 and we get a number with more than 2,000 digits. Lastly, what about 6 to the third tetration? Or 6 to the power of 46,656? You might ask. You don't want to know the answer. That is going to wrap up today's video. In the next video, I will do factorial and breaking math rules. Thanks for watching. See you next time.